Yes, let's discuss the Harry Markowitz mean variance model. This is the fourth and the final portfolio theory that we are going to discuss. I'm sure it brings a smile on your face, isn't it? Eventually, the portfolio theory discussion is finally coming to an end. Now, if you see this model, we call it as a mean variance model. It's many a times even referred as the modern approach to portfolio management. Fine. If we see the title, they are saying mean, right? By mean, we are referring to return. And by variance, we are referring to risk. You are using the term variance. The moment you say variance, that means you are considering both systematic as well as unsystematic risk. If I am considering only systematic risk, then I will consider only the beta. But here we consider the variance. So very much like the market model, here also we are considering systematic as well as unsystematic risk. So the total risk will be considered, and we are supposed to bring about an optimum balancing between risk and return, and thereby select the right securities for us, or we can say the right portfolio for us. Now, this particular approach introduces a new concept. That is what I will like to discuss first. We call it as efficient security, or you can even say efficient portfolio. So if you are discussing Harry Markowitz mean variance model, then our selection of securities will be based on efficient. So the way this model works is, the first step is to decide what is the total amount of money that you want to invest in the different securities. Let us say we are selecting risky securities. I want to invest in the stock market. So I will first make a list of different shares that I am interested in. Once you are ready with the different shares that you are planning to invest in, then for each of those shares, calculate the return and the variance. Okay, return, dividend plus capital appreciation divided by MPS at the beginning, right? So you can use that formula and work out what is the return of the security, and then calculate the risk of the security. You can calculate the risk as variance. You can even calculate the risk as standard deviation. That's fine. So for every share that you are interested in, this is the basic statistical analysis that you are supposed to carry out. Once you have done it, you have to now segregate the selected securities into efficient securities and inefficient securities. So either a security is an efficient security or it is an inefficient security. Inefficient securities will be rejected. Okay, I will not invest in inefficient securities. I am interested only in the efficient securities. So first, let's try to understand this really well. When can we say a security, or when can we say a portfolio is efficient? Because if it is efficient, then and then only it is worthwhile accepting. If I come to the conclusion that the security or the portfolio is inefficient, I shall outrightly reject it. So let's understand what is this concept of efficient and inefficient securities. We'll take some figures and it will become really clear. So what we do is try to understand the concept of efficient security or the portfolio. As I said, for every security that you have shortlisted, calculate for that the return and the risk. Let me consider two securities over here. This concept of efficient security or efficient portfolio is defined in a negative manner by Harry Markowitz. But see here, let us say there is a security A which is giving 18% return at 8% risk. And there is another security B which is giving 20% return at 6% risk. Tell me, which one will you select? Let's say I have a choice between A and B. I cannot select both. I have to select any one. If these are the figures, tell me which one will you select, or in other words, which one will you reject? So if you see here, A is giving 18% return at 8% risk, while B is giving 20% return at 6% risk. Please do not do any calculations over here. Don't try to calculate the coefficient of variance, CV that we had discussed earlier. No, just by observation, tell me which security should be selected, which security should be rejected. Tell me. Will you reject security A and select security B? Right? Security B is considered to be an efficient security. Security A is inefficient. If there is any security which is giving you higher return at lower risk, that means your security is an inefficient security. As you can see, security B is giving higher return compared to A, and that too at a lower risk. So obviously I will accept security B and I will reject security A. In terms of Harry Markowitz model, security A is inefficient and security B is efficient. Okay, let's take one more possibility. Let's say there are two securities A and B. A is giving 18% return, B is also giving 18% return. But this is the risk now, 8% and 6%. Tell me, will you invest in security A or will you invest in security B? Think of it. What do you say? Security A and B both are giving 18% return, same return. But security B is giving 18% at a lower risk. That means A is inefficient and B is an efficient security. A security is an efficient security only if there is no another security which is giving you same return at lower risk. Okay, let me take one more example. %18 return and 20% risk. Sorry, 20% return. 8%, 8%. Tell me, where will you put your money this time? Will you select A? Will you select B? Again, A will be rejected and B will be accepted because B is giving you higher return at same level of risk. So that is the concept of an efficient security or a portfolio. As I said, it is defined in negative. I will say a security or a portfolio is efficient. Just see, is efficient only if there is no another security or portfolio which is giving higher return at lower risk, same return at lower risk, or a higher return at the same level of risk. So these are the things that we have to keep in mind. As I said, the first possibility is where there is higher return but at lower risk. In the second situation, you are getting same return at lower risk. And in the third one, you are getting higher return at same risk. So a security or a portfolio is efficient if there is no another security or portfolio which is giving higher return at lower risk, same return at lower risk, or higher return at the same level of risk. So step number 1 under Harry Markowitz model, decide what is the amount that you want to invest in the stock market. Based on that amount, decide which are the shares that you are interested in. That means make a short list, certain number of shares. Let's say I want to design a diversified portfolio. So from every sector, I have selected some 2-3 shares. And I want to now decide that in which share should I invest in. For all the shares that I have decided to invest in, I will calculate the return and risk. Then I will compare the return and risk. And there are certain securities which are inefficient securities. all those inefficient securities will get rejected and I'll be left with efficient securities. I will invest only in efficient securities. Even amongst the efficient securities, then I will find out which one is the best. That is yet another step that we have to take under the Harry Markowitz model. But before that, as I said, we should be very clear with the concept of efficient securities. Let's do it in this way. Let's build one illustration and understand how shall we now decide which is the best security or the best portfolio for us to invest in. Let us say you have shortlisted some shares. Let's say the returns are 20%, 4%, 8%, 32, 32, and 36, let's say. Risk, let's say, is 8%, 8%, 10%, 10%, 14%, and 18%. So what I'm doing is I'm making a list of the different shares which are available in the market exactly the way it is suggested in Harry Markowitz. And then I've calculated their returns and I've calculated their risk. Now, we will apply the rationale of Harry Markowitz model out of the list that you have prepared. Out of the list that you have prepared, we are supposed to decide first that which are efficient securities and which are the inefficient securities. Just see, check with A. A is giving 20% return while B is giving 24% return. B is giving you higher return at the same level of risk. So you know what I will do? I will reject A. Okay. Now B and C I cannot compare. Yes, C and D can be compared. 10%, 10%, but D is giving at a higher D is giving a higher return. So I will reject C. Okay, D and E, 32, 32, same return, 32, 32. But D is giving at 10% risk. Great. So I will reject E. E is turning out to be inefficient. See, there is nothing to compare between B, D, and F. Because what happens in B, D, and F is the risk is increasing, so is the return. So fine. I can say that B, D, and F under the Harry Markowitz model are efficient securities. But I want to invest only in any one of the three. Tell me. I want to invest in only any one of the. So how will now I decide which is the best security for me? You get my point? I have been able to identify efficient securities, but I have not been able to identify optimal security, which is the best security for me for investment. How will I decide this? Now, in order to understand this, we will have to now discuss altogether something else. See, what we will do is we have to carry out a right balance between risk and return. Again, I am making it very clear that when I say I will balance risk and return, I am not planning to calculate coefficient of variation. Earlier, we had understood one concept of CV. No, Harry Markowitz model is not based on CV. It's not such a simple model that I just work out the CV over here and say, yes, this is the best share for me. No, Harry Markowitz has given a proper manner in which the risk return can be balanced by us. It is popularly known as risk return trade off. Okay, I will like to explain that thing to you. What I'm discussing is market risk return trade off. By trade-off, we mean we are balancing risk and return. As an investor, I want to decide that out of those three earlier efficient securities, which one is best for me. So now what I will do is I will like to take a calculated. If you see here, security B can be selected where the risk is 8%. Security D risk is 10% and F risk is 18%. If my eyes are on risk, then I will feel that B is good because B has a lower risk. If my eyes are on return, I will be like that, okay, let me go for F because F is giving the highest return. But portfolio management is not based on this. Please understand this very well. Portfolio management assumes that an investor is rational. An investor is ready to undertake a well calculated risk. So that is what I want to do now. I want to take a well calculated risk, and that I will do by going for the market risk return trade off. Market risk return trade off. What does that mean? I will ask myself that as far as the market is considered, by market I mean, let us say, the Bombay Stock Exchange, National Stock Exchange, where such a large number of people are participating, right? There is such a large number of people who are every day buying and selling shares on the Bombay Stock Exchange and the National Stock Exchange. So, what is the risk return balancing that the market is doing? By market, we mean market portfolio. And by market portfolio, we mean the securities which are available in the market. Now, we had discussed this earlier also, that market portfolio means an entire universe of securities which are trading in the market. Now, this can become too huge of a concept. That is the reason in portfolio management, we narrow down market portfolio to the index that you are tracking. Either you are tracking Sensex or you are tracking Nifty. So what I will do is I will find out what is the risk return trade-off of the market portfolio. Getting it? What is the risk return trade-off of Sensex? What is the risk return trade-off of Nifty? When such a large number of people are participating in the stock market, the information that I will get on the basis of Sensex, the information that I'll get on the basis of Nifty is a result of the collective wisdom of such a large number of people. I can definitely rely on that. See, I may not rely on you as a person. If you come and tell me that this share is worth buying, I will not rely on you. But if I observe on the stock market that majority of the people are buying this share or majority of the people are selling this share, then I will feel that they know something which perhaps I do not know, right? That's what I'm saying. We may not rely on an individual, but we have to rely on the collective wisdom of the people at large. So I will introduce a very new concept over here and explain you that how this market risk return trade-off will take place. Okay. Harry Markowitz mean variance model now introduces what we will call as the capital market line. Show you how that will be done. On x-axis, we will consider the risk, which will be measured by the variance or measured by the standard deviation. And on y, I plot the return. Okay, now this is 0 over here. So that is your risk. When risk is 0%, that does not mean your return will be 0%. When risk is 0, your return will be equal to the risk-free rate of return. Okay, now what I will do is I will now plot the market portfolio over here. Market portfolio, the Sensex or the Nifty, or for that matter, any other index that you are tracking. Okay, any other index that you might be tracking. So I plot the market portfolio over here. So let us say this is RM, return of the market portfolio. And let us say this is the risk, right? The risk of the market portfolio. So yes, I plot from here, just bear with my graph over here. This is what I'm getting now. This is the place where we have, this is the place, just a second. This is where I have the market portfolio. And now I have these 2 points, right? This point and this point. I will join these 2 points. This line that I am getting, I will refer this as CML. By CML, I mean capital market line. What is the significance of capital market line? Capital market line will give me what is the market risk return trade-off. How is the market balancing the risk and the return? That is what we are getting here. Just a second. Carry out the market risk return trade-off. How will I do that? This is done by calculating the slope of capital market line. So I'll work out the slope of CML. The slope of capital market line, it is given by RM minus RF divided by sigma M. This will give us that for every percentage of risk that you are taking as an investor by investing in the market portfolio, how much additional return are you demanding? That's the concept of the slope of CML over here. So this is the CML that I have on the screen. How do I get the capital market line? Join risk-free rate of return with the market portfolio and just join a straight line, right? I'm getting an upward sloping straight line over here. And then I work out the slope of the CML. Slope of CML, as I said, is the risk return balancing which is done by the market. Take some figures and it will become more clear to us. So slope of capital market line. Let us assume for a moment that RM is 20. Let us say RF is 10 and market standard deviation is 5. I'm just assuming that market return is 20%, risk-free rate of return is 10%, and the risk of the market, let us say, is 5%. This is what I'm doing. So this will be 10 by 5, so I get 2%. So your slope of capital market line is turning out to be 2%. Question is, what do we really mean by this 2%? How will I interpret this 2%? Very interesting. What is this 2%? I want to interpret this 2%. Now, you have divided it by market risk, right? You have divided by market risk. So what it means is for every 1% risk, see, for every 1% risk, investor demands 2% return over and above risk-free rate of return. Does it make sense? Just see, 20 minus 10 divided by 5, right? What I have done here is 20, which is your RM, and 10 is your RF. So I'm deducting the risk-free rate of return. Why? Why are we deducting the risk-free rate of return? That's also very interesting. See, if I do not take any risk, I am getting 10%. See, there is nothing great about this 20%. Understand this. RM is 20%. There's nothing great about it. If I do not take any risk, I am in any case getting 10% return. 10% return is already available. But when I take risk and invest it in the market portfolio, I get additional 10%. You get it? My eyes are not on 20%. My eyes are on the additional return. The market market portfolio gives 20%. So what? Even if I don't take any risk, I am getting 10% return. Market portfolio becomes attractive not because it is giving me 20% return. Market portfolio becomes attractive because it is giving me 10% more than the risk-free rate of return. That is what I'm interpreting over here. When you say that the market risk return trade-off is 2%, 2% means for every 1% risk that you are taking, you are demanding 2% return. 2% return in addition to the risk-free rate of return. In addition to the risk-free rate of return rate. So this is your market risk return trade-off, 2%. Okay. Let me return back now to the original illustration that we were doing, right? The original illustration. Here it is. What I want to do is I want to now calculate here I want to calculate now over here return based on CML, based on the capital market line. I will not do any calculation for A. A is already rejected. So I do the calculation for B. Please look at it. The way we are planning to do it. See, the risk over here is 8%. Now, what was the logic of CML? For every 1% risk, I require 2% return. So 8 I will multiply by 2. So I get 16. But this return should be in addition to the risk-free rate of return. In other words, 16 should be added to 10. I get 26%. I'll write and then again I'll discuss that thing once again. Again, I repeat for you. What do you say? The slope of CML is showing the market risk return trade-off of 2%, right? It is showing of 2%. That means for every 1% risk, you are demanding 2% return, 2% return. So that is what I'm saying here, that my risk is 8. And for every 1% risk, I want 2% return. So my risk is 8. I multiply that by 2. That means I require 16% return. But 2% is not total return. 2% is return in excess of the risk-free rate of return. And we assume that the risk-free rate of return is 10. So I get 10 plus 2 into 8, which is equal to 26%. Okay. What will happen here? C is rejected. Let's check with D now. See, security D, it is having a risk of 10%. For every 1% risk, I want 2% return. So 10 I multiply by 2. So I get 20. 20% over and above the risk-free rate of return, which is 10. That means it will turn out to be, yes, 30%. I say it is 10 plus 2 into 10, which is turning out to be 30%. Comfortable? And now E is also rejected. So finally for F, I will do the calculation. For every 1% risk, I require 2% return. So I say 2 into 18. So that is 36. But 36 is over and above the risk-free rate of return. So I add 10 to it. Now this is turning out to be 46. This will now help me in selecting the optimal security. It's very much there on your screen. What do you say? It's very much there on your screen, isn't it? See, I should get 26% return, but this security is giving me 24%. It is giving me less than what I desire. The last one. I should get 46% return, but the security is giving me 36% return. It's giving me less than what I require. And now just see here, this security should give me 30% return. If I do a very good risk return balancing, I should get 30% return. But this security will give you 32%. It's giving you more than what is required. What does that mean? It means security D or portfolio D is the optimal portfolio or the optimum security. So the optimum security, the optimal portfolio is finally available. That's how I apply the Harry Markowitz model. Step number one, decide what is the total amount of money that you want to invest in the stock market. Step number two, out of that budget, now make a list of the different shares that you can invest in or the portfolios. Step number three, for every security or portfolio that you have designed, calculate the risk and the return. Next step, identify which are efficient and inefficient, reject the inefficient ones. Right? Next step, find out what is the risk return balancing that the market is doing. And based on that, work out the return for your efficient securities. Now do a comparison. Compare the efficient securities with the returns that they are going to provide and identify or decide which is the best for our investment. That is, in nutshell, the Harry Markowitz model. One more thing. Based on these calculations that you have done, you can design the entire formula for efficient securities. See, ER equals 2. This 10 is nothing but RF, isn't it? So that 10 is nothing but RF, right? This 8 is nothing but the risk which I'm multiplying by 2. 2 is nothing but the slope of CML. So I can say it is slope of CML into sigma s. What do you say? RF plus slope of CML into sigma s. In case if portfolio is given, then instead of sigma s, use sigma, and you will get the efficient, what you can say, the return of an efficient security or an efficient portfolio.